Okay, students, this is lesson 138, the method of constant differences. In this lesson, we're going to learn that in the relationship between two variables, if the change in both is constant, then the two are linear related. So we have another way of finding out if there's a linear relationship. And then if there's a linear relationship, we can write a rule for that. All right, so you'll notice, I'm going to skip the first two tables here. I'm going to do table 3 and table 4. So what I'm looking for is the difference between the values in the input and the output. Now the input is just the x values, the output is the y values. So if I look at the inputs, I notice these are all going up by 1. So all I'm doing is subtracting consecutive values there. And in the output, I notice that I keep dropping 2. Well, since there's a constant difference in both of those, I'm going to, I think this is linear, a linear relationship. Okay? And then in the second table here, my input is going up by 1 each time again. My output is going up by 5, then 6, then 7, and I get that by subtracting any two values. So in this one, and also remember that the difference in the x values, so these numbers up here, those are our runs, and our difference in our y values, that's our rise. And if we have the same ratio of rise over run throughout the table, then it's a linear relationship. In this one over here, you'll notice that if I look at the ratio of rise to run in these three, I have 5 over 1, 6 over 1, and 7 over 1. So the ratio of rise to run is not constant, as shown by the constant differences, or these are not constant differences. Okay, so I think this one is not linear because we're not going up by the same amount in both the input and the output. So I have a special guest to help decide if I'm right or not, an expert here. So I'm going to check out by, see if I can.
Lucky.
Oh, all right. So let's go on to the next. Oh, wait a minute. If it is a linear relationship, we're going to try and write the rule for that. So we're going to write the rule right now for this. And the rule is y, which is the output, is equal to negative 2x, because we're going down each time 2 for every increase of 1 in the input. And then we're going to do plus 29 because we start at 29 when the input is 0. Okay? And the other relationship, it's not linear, so we're not going to worry about writing an equation for that. All right, let's go on to the next page. And let's try a couple more here. So again, we're going to guess whether we think it's linear or not. And I'll do a couple here again. In this first one, we can see that the inputs all go up by 1. And the outputs, if I do 3 minus negative 7, I get 10. 13 minus 3 is 10. 23 minus 13 is 10. And 10 and 10 and 10. So we see that there is a constant difference in both the input and output. So our guess is that that is going to be a linear relationship. And since it's a linear relationship, we're going to write the rule. Y, our output, is equal to 10x. And we get 10 because that's our slope, 10 divided by 1, or our constant rate of change. And then at 0, when the input is 0, the output is 3. So we're going to add 3 to that. Okay? All right, on this next one, we're going to go ahead and do the inputs and outputs in that, the difference between the inputs and output. Here we're going up 2. Here we're going down 1. 1 minus 2 is negative 1. 5 minus 1 is 4. 4 minus 5 is negative 1. 3 minus 4 is negative 1. And then on our outputs, 16 minus negative 2 is 18. 7 minus 16 is negative 9. 43 minus 7 is 36. 34 minus 43 is negative 9. And 25 minus 34 is negative 9 also. As it looks right there, you might suspect that this is not a linear relationship, but we're going to look a little closer. Remember, these are our runs, these are our rises, and if we have the same ratio of rise to run, which is the slope, for every problem, then it still could be a linear relationship. So if I divide these two numbers, 18 divided by 2, I get 9. If I divide these two numbers, negative 9 divided by negative 1, I get 9. 36 divided by 4 is 9. Negative 1 divided by negative 9 divided by negative 1 is positive 9. And I do get 9 for every ratio of the difference between the outputs and the difference between the inputs. So that means I have the same slope all the way along. So yes, it is a linear relationship. And our rule is y equals 9x minus 2. And I get the minus 2 from 0 on that graph. All right. So let's try another one here. Check this out here. And this one, if I do 2 minus 3, I get negative 1. 1 minus 2 is negative 1. 5 minus 1 is 4. 4 minus 5 is negative 1. That's the difference between my input values. My output values, 25 minus 15 is 10. 35 minus 25 is 10. 45 minus 35 is 10. 55 minus 45 is 10. Now, on this one, it might appear that the numbers are going up by different amounts here. So you might say right away that you think this is not a linear relationship. So let's check a little more closely. Let's check out our ratio of rise to run here. So 10 divided by negative 1 is negative 10. So that means I'm going down 10 there, down 10 there. 10 divided by 4 is 2.5, and 10 divided by negative 1 is negative 10. So what that's telling me is we don't have a constant rate of change, that it's fluctuating. So we're going to go with our no. Since we have a no, we're not going to write the rule. But just to make sure, we're going to graph this to check our results. And if it's a linear relationship, the dots should all line up. If it's not linear, nonlinear, then they shouldn't all line up. So I need to graph output values that go to 55. So on this graph, I'm going to go by 5s. And that gives me 50, which I'll just go a little bit higher than 55. All right, and then on the x-axis, I'm just going to go by 1. Okay, so then I'm going to graph the points 3, 15, that's right there. 2, so I'm doing these points here, 225, 135. Boy, so far they look like they're lining up really nice. 545. Ooh, that one's a problem. And 455. That's like way up here. So my points, as I go from left to right, go down and concentrate for a little while, and then they go up, and they go back down. So that's definitely nonlinear. All right. So I think we'll call it a lesson here. One thing you might want to try is just maybe look at some of these tables, and I'll let you do this. See if you can't find the 2 missing values. Then we'll talk about how we can write the equations for those in class next time we meet. All right, that's it here.